Welcome to the future.
Welcome to the Muxall Open Internet of Things video blog. I am your host, Michael Crane. Okay, so this video is just a quick video announcing a Kickstarter I have running right now. I started it at Christmas, and it's currently running. Looks like we've got 12 backers. got a little ways to go from our $9,000 goal, but I wanted to at least put it out there on the blog so everyone could go check it out if they like and buy some of these things if you find the need for them. It's the Muxall infrared detector that we designed in the Muxall Open IoT video blog. If you've been following along, this design was based on the OSEP design that we reversed engineered. I didn't create this design. I just kind of modified it and upgraded some of the parts and made it a little better. Yeah. And the price is right. Let's see. It's $5 for the kit and $9 for the detector, and that's with free shipping. So if you go to Amazon.com, and I don't usually trash other people's products, but I just wanted to show you that you can buy 10 of these Osoyos, I don't know, IR obstacle avoidance sensor module for Arduino smart car robot. 10 of them for $10 and free shipping. And that seems pretty doggone good. The problem with them, you can see right here. So you got the infrared LED, this clear one, this infrared sensor right here. And that's just a plain Jane infrared sensor. I could probably go on DigiKey and look it up, but I'm not going to waste my time doing that. The thing is it doesn't have any analog control, any automatic gain control. So if you put this thing in front of a IR window, it's not going to work. Like if you wanted to make a toilet, right, that had, a nice little infrared dark piece of plastic in the toilet lid, so you could wave your hand over it to flush the toilet, it's not going to work, right? Because it doesn't have the analog gain control. I mean, it's dirt cheap, right? So if you look at some of their reviews, you can just see the problems they're having. Yeah, so one of the problems this guy, talks about is that the light sensor and the light are right next to each other. And even on my board, they're pretty damn close. But you have to admit, it's further away than these guys are, right? These are literally right next to each other. But that, like I said, that the automatic gain control can take care of that. They're trying to stick a divider in there, which is a good idea, but you're going to get any kind of light noise is going to cause the problems. Yeah, you can see that even the distance is I'm surprised he got 6 to 7 inches out of it. I wouldn't have thought you would have got that far with it. This guy is saying it's got a high failure rate, but it's susceptible to natural light. Yeah, see, that's bad. This guy likes them. They're cheap. It only works within 3 inches. Well, yeah. And this guy's, you get what you pay for. Only lasted a couple weeks. Anyway, you can read through these. Like I said, I didn't want to just sit there and batch them, but the IR detector that we have here, this is a Vishay IR receiver. It's got, let me pull up the spec sheet on it. For one thing, so it doesn't get interfered with sunlight or any other kind of noise, light, body heat, and that sort of thing. It's got a internal filter for PCM frequency. I've got them at 38 kilohertz. but actually the IR detector on the Kickstarter here is adjustable from 38 to 56 kilohertz. So you could actually, put a 56 kilohertz receiver in it. But the biggest thing is this automatic gain control right here, and what that does is let's see if we can read it here. Let's see, when data signal is applied to the product in the presence of a disturbance, the sensitivity of the receiver is automatically reduced by the automatic gain control to ensure that no spurious pulses are present at the receiver's output. And it gives some examples. DC light from light bulbs, sunlight, continuous signal at any frequency. That would be like if it was in front of that IR window I was telling you about. And modulated patterns from fluorescent lights and electronic ballast. So, and you need this if you're going to put it behind a window. And if you want to get any kind of distance out of it. So if you're wondering why the goal of $9,000, the reason is, let me pull up the bill of materials here. So here's the bill of materials for just one IR detector. This isn't including shipping, right? This is this is just the parts off of DigiKey. And so if you're going to go buy these parts, and this thing is not really up to date, but anyway, it's close. I need to update it. But if you're going to go buy these parts, it's going to cost you about $4.90 just for the electronics, right? And I don't see the PCB cost isn't even in here. So if you look at the Kickstarter, the detector kit I'm selling for $5 plus free shipping, right? And the only way I can do this is I've got to order enough parts I need to order 1,000 of each of these parts, right? To bring the cost of these parts down, basically cut them in half, right? And that's why the goal of $9,000, because, it's if I was just selling kits, the goal would be, I guess, $5,000. But if people order 1,000 assembled boards, the assembly is going to cost at least $4 a board, at least last time I checked. So that's about it for this video. I just wanted to announce the Muxcell IR detector Kickstarter is running. If you have any questions or comments, leave them under the comments under the video. Try to answer them the best I can. You can jump over to the Kickstarter. I'll leave links under the video as well so you can get to it. And I'll see you next time.